Okay, 2020, paper 2, question 1. Find the coordinates of all 3 points, A, B, and C, given there. Find the perpendicular distance from A to BC. Based on your answers, what can you conclude about the relationships of A, B, and C? Okay, perpendicular distance from A to BC, specific formula. That's the absolute value of AX1 plus BY1 plus C, all over the square root of A squared plus B squared. Okay, to use this formula, you're going to need a point and you're going to need a line. So the distance is from the point A, so A, 2 minus 6, that would be our x1, y1, to BC. So BC is our line, so we're going to need to find the line BC. Find line BC. To find the equation of a line, we use our formula, y minus y1 is equal to m times x minus x1. So we need to know two things. We need to do a point on the line, and we need to know the slope of the line. Let's start with our slope. So it's the slope of the line BC, so we'll let this be x1, y1, this be x2, y2, and we'll fit into our slope formula. y2 minus y1, so that'll give me plus 12, all over x2 minus 4 minus x1, which is minus 6. So that is going to give me 15 all over minus 10, dividing by 5, that's going to give me 3 all over 2, minus 2, or minus 3 over 2, minus 3 all over 2. That's the slope of the line. Now we need a point on the line, so let's just use the point B. So then y minus y1, y minus 12 is y plus 12 is equal to m times x minus x1, x minus 6. Okay, we'll multiply everything by 2. That'll give us 2y plus 24 equals minus 3x plus 18. Get them in the right order. So 3x plus 2y and 24 minus 18 is going to give me positive 6 is equal to 0. Okay, so that'll be my line. And this will give my A, my B, and my C. And I have my x1 and y1. So filling them in, the absolute value of AX1, so that's 3 times 2, plus BY1, that's 2 times minus 6, plus C, that's plus 6. All over the square root of A squared plus B squared, that's 3 squared plus 2 squared. So that's going to give me the absolute value of 6 minus 12 plus 6, all over the square root of 9 plus 4, which is going to be root 13. 6 minus 12 is minus 6 plus 6 is going to be 0. So 0 over root 13. So the distance from the point to the line is 0. If the distance from a point to the line is 0, then the point A is on the line AB. If it's on the line, on the line BC. If it's on the line BC, then its distance to BC is 0 because it's already sitting on it. B of this diagram shows two lines A and B. The equation of A is x minus 2y plus 1. The acute angle between A and B is equal to theta. B makes an angle of 6 degrees in the positive sense of the x-axis, as shown in the diagram. Find the value of theta in degrees correct to 3 decimal places. So look, there's probably a lot of different approaches to this, but I suppose the first thing that comes to my mind is if I'm looking for the angle of theta, I'm looking for the angle between two lines, which is going to be this formula here. Of course, to do that, I need to find a slope for the first line and a slope for the second line. So I have the equation of the first line, it's x minus 2y plus 1 equals 0. So if I want the slope of that, I just rearrange it. So minus 2y is equal to minus x minus 1. So y is equal to minus x over minus 2 minus 1 over minus 2. So y is equal to x over 2 plus a half. So the slope of the first line, we call it m1, is a half. Okay, so it's rearranged in the form y equals mx plus c. Now we need the slope of line B. That's kind of tricky, but because we can see that it's making an angle with the x-axis here, I can find the slope of that line using rise over run. So if I look, for example, here, if I pick a point, let's say here, and then here, and I call this my run, and this my rise, then I can find my slope. Of course, if we've got an angle of 60 degrees here, this is a 90-degree triangle, the rise here is of course the opposite, and the run is the adjacent. And of course, opposite and adjacent are used in tan. So tan 60 degrees must be equal to opposite over adjacent, or in this case, rise over run. So I look up my tan of 60 degrees and I get root 3. So root 3 is the slope of that. Okay, so my M2 is root 3. So now I'm going to put all that into my formula. Okay, so my formula then is tan theta. Tan theta is equal to the positive and negative, I don't really care which one, M1 minus M2 over 1 plus M1 M2. Fill in my bits and pieces. So tan theta is equal to a half minus root 3 over 1 plus a half times root 3. Okay, so then if I want theta, it's just going to be the tan inverse of all of that. So half minus root 3 over 1 plus a half times root 3. Okay, so our theta then is going to be, to get theta of 33.435 degrees.